test review, take one. Okay. So when we're talking about similarity, we're talking about proportions, right? And so that's like the main idea. And this is a common picture that we see. And it has to do with the side splitter theorem, because if we have parallel lines, it splits the sides. So if we know that we have something like this, we can figure out what x, I'm going to get used to that, what x is pretty quickly, okay, because they're both sides. And we can write a proportion. What would the proportion be? Perfect. X over 4 equals 5 over 10. It becomes a problem now if I put the 5 and the 10 here, because x over 5 equals 4 over 10 is not right. Okay, they're not the sides. So what would the proportion be in this case? Good. Okay, because we know that we have to do little triangle and big triangle. That's one of the big things you have to remember. Okay, it sounds to me like we've got that part. In this case, if I did cross multiply, would I have anything quadratic at all? Anything with an x squared? Nothing. So I wouldn't have to worry about factoring or taking square roots and reducing radicals or any of that stuff. And it sounds to me like that's where we're struggling a little bit. Okay. So I think was it the test review, or one of them had some examples where they had some quadratics. Do you remember which one it was? We can look through those. I think it was this one. It was that reteaching sheet, right? Oh, yeah. There was quite a few factoring ones. Did I go over all of those in class with you, or? Okay, but I didn't actually go over them. All right, so let's do one. All right, so which one? You think 12? Does that look good to you? Okay, let's do 12. Do you mind if I just borrow someone so I can give the picture drawn? No, I did picture. Hey, Devin. All right, so what we're doing is hang on. All right, so if we look at number 12 here, we have 3 parallel lines cut by a transversal. We have 8x, 2x plus 2, 10.5, all of which are parallel lines. Okay. Now, in this case, does the side splitter theorem actually apply? It does, because it's sides, right? They're not talking about the bases or anything of the triangles or anything like that. So the proportion is going to be
x over 10.5 equals x over 2x, x cubed over 2x plus 2. 8 over 2x.
Okay, thank you. Do you agree with that? Do you agree with the proportion? I do too. All right, so what this means now is that when I cross multiply, I'm going to end up with a quadratic equation, okay? And that's where I think a lot of us are struggling. How do I deal with the quadratic equation? So when I multiply 10.5 by 8, I'm not a human calculator. What is that? Come on, Alex. You guys are human calculators. I get it. All right, and then over here, I go ahead and write it this way just to remind myself to distribute, okay? And then we're going to distribute. And x times 2x is 2x squared. People want to say 3x, so that's only when you add. So it's 2x squared plus 2x equals 84. So we have to remember, in this case, when it's quadratic, how do I solve a quadratic equation? Get it equal to 0. And then there's a couple of different ways we know how to do it.
Also, can you use the quadratic formula?
Sure. A quadratic formula will always work. Okay? Yeah, but I think all the ones I will give you will end up factoring. So I think that's typically what we do in class is just factor them all. But the quadratic formula will actually always work too. So you just have to remember how to, you have to remember what the formula is. And then you also have to remember how to reduce radicals, which is another issue that people seem to have as well. So either way works. But I think we should get it to equal 0 first. They don't know how to complete the square yet, so just so you know. All right, so 2x squared plus 2x minus 84. Okay. So if I wanted to factor, how would I start? I would take out the GCF, which happens to be a good. All right, so I'm going to take a GCF out. And when I do that, I'm left with this. Okay, now what? All right, so I typically draw a little X here, and I say they have to multiply to be negative 42, and they have to add to be 1. And it's kind of a numbers game here. You have to kind of guess and check to figure out what numbers are going to work. So factors of negative 42 could be 6 and negative 7. It could be negative 6 and positive 7. It could be 42 and negative 1. I mean, there's lots of choices, right? Which choice of factors actually add to be positive 1?
Positive 7, negative 6.
Right, positive 7 and negative 6. So what that means is that in the 2 stays, and I have x plus 7, x minus 6 equals 0. Okay? So I factored it. Again, they have to multiply to be this number. They multiply to be this number, and they're going to add to be this number. If there's not a number there, it's assumed to be 1. Okay? Now, once it's factored, it's still not solved. How do I solve it? Yeah. 2 never equals 0, so I don't have to really worry about the GCF part. And actually, I know that negative 7 is not a solution because so it's negative and it's a length. So I know that 6 is my only solution here. Do you want to try it with the quadratic formula? So you can would you feel more comfortable with that one rather than factoring? Okay. Now again, only if it's quadratic, right? But we'll try it. Would you quadratic formula from the beginning, or would you quadratic formula, where would you, from here? Would you do it from this point? Okay, that's fine. It doesn't matter. So remember what the quadratic formula is. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we have to remember what a, b, and c are. In this case, what's a, b, and c? A is just 2. It's a number in front, and b is? So a is also, or b is also 2. So we have a, we have b, and we have c. The signs go with it too, okay? So b is positive 2. The formula says negative. So it's going to be negative 2 plus or minus b squared. I put parentheses there because if b is negative, you have to square the negative also. Minus 4ac all over 2 times 2. Again, if you prefer, factoring is a lot quicker. A lot. This is a lot more entailed. How do I reduce this? What do I do first? Perfect. Okay, it's called the discriminant. Not that you need to know that, but I'm going to figure out what the number under the radical is. Tell me what that is. Go ahead and use your calculator. If you need a calculator, grab one. I don't care. Use your phone. I don't care. Figure something out. What's 4 plus, because the negative times a negative? It'd be a pretty big number. So I did get 676. Did you get that? Try it. I want you to plug it in. I want you to try it. Get a calculator. Make sure you get that number. And you said it reduced to what? What's the square root of 676? 20. Who was it?
Oh, 26.
Thank you. Now at this point you have negative 2 plus 26 over 4 and negative 2 minus 26 over 4. And guess what? The answers are negative 7 and positive 6. 24 over 4 is 6. That's a lot of work rather than factoring.
I get love that. Yeah.
Okay, if you're comfortable with the quadratic formula,
But I think I like that one.
okay, I mean, it's just,
Completely forgot.
it's okay. You can do it either way. It's just that it takes a lot more work. There's a lot more room for error. But if you can't, sometimes finding the two numbers to get it to factor is what takes you a while, is figuring out what these two numbers are. How did you do it on the calculator?
Oh, we got calculators.
So For the ones I give you, most likely the leading coefficient will be 1 and it will be factor, and so you could use that table. That's fine. Okay, so that's, hey, it's a toolbox, use it. You know, if you got someone, use it if you can use it. That's fine. I will tell you though, on the test, there is only like one that's a factoring one. It's not heavily hit. Okay? Yeah. You are now in the calculator-free zone, okay, of geometry, so you're allowed to use a calculator. Yeah, I actually learned of an app. They're here for you. You need help? They're here, seriously. Yeah, find it. Okay. So again, there's not that many factoring ones, right? So we don't have to worry so much about that. I'd much more worry about the actual stuff, like the geometric mean stuff, right? Or the right triangles, and do you know what the geometric mean is? There's a whole section on the test just on right triangles and similarity, okay?
You know when you're like using like square roots or something?
Okay, let's look at those. All right, so I'm just going to borrow, since you have it out, the geometric mean questions. Let me just pick some. Is that okay with you? Let's look at the, is there any on the test review, actually?
They're geometric means.
Yeah.
Wait, actually, I understand the geometric.
Well, that's good, but
then
maybe,
we have to like reduce the ratio. Yeah.
See,
I'm
yeah.
horrified.
Let's do 18 on the geometric mean page, okay?
I got it.
Okay, let's start with that, okay? So first of all, what tells me here that I know I need to use the geometric mean? Right, I have a right angle, I have a right triangle, and I have an altitude in there. So I've got 2 right angle marks. I always like to highlight the geometric means. Yes, baby? All right, so here we are. The 3 things I have highlighted are the geometric means, right? So that means that if they are a geometric mean, they go here and here. X is one of the highlighted segments. What's X the geometric mean between?
6 and 8.
6 and 8, good. Now, if you don't remember you can just kind of draw it here. It's between the part of the hypotenuse that touches in the whole thing. Okay? That's really the only way to solve this one. Sometimes, there was one in class we did this morning, or maybe it was 6 o'clock, I can't remember, where I had one of these, like let's say that I knew what the answer to this is. It's not this answer, but what if I knew what y is? Couldn't I just use this right triangle to do the Pythagorean theorem? Right? But I don't. I have 2 missing variables. I have to do a geometric mean here. Cross multiply. This is the part you guys struggle.
Yes.
Reducing the radicals. So I will give you most credit if you leave your answer like this. You will not get full credit unless you reduce the radical properly. Okay? And that's what I'm going to have Devin and Andy work with you guys on. Okay? Huh? Anthony! Did I say Andy? I'm sorry, Anthony. Sorry. Dupre, I know your last name.
If we were to get the radical right, and then we reduce it wrong,
I would still take off some points. Okay? So we got to reduce it right. And I think every single one of you need help with reducing radicals. Okay? So let's divide up into groups of 2. Okay? Each of us is going to take a pair of you. All right? And we're going to reduce radicals. So would you guys grab some whiteboards and some markers behind us? And we're going to literally just practice. We're going to reduce. I'm going to put like 5 of them up on the board. Okay, good. So that's why we're doing it, okay? So we're going to reduce the following radicals. You with me? We're going to reduce for the square root of 48. These are the ones we're going to practice. So literally, take your whiteboard and go move to a different table. There should only be 2 people and you at a table. So square root of 48, square root of 96, square root of 125, and the square root of 500. Let's reduce all 4 of these and see how well we do, okay? And you guys hopefully found all of these. I think this one was 5 radical 5, 10 radical 5, Remind me. Jason, do you remember what 48 was?
48 was
12
and 40.
8 and 6.
And since that was 4 and 3, it would be 4 to 3.
4 radicals.
Yes.
And then how about the square root of 96?
That'll be 12 and 8.
Square root of
8 that'd be
6 root of 3.
3, 4, 2.
6 root of 3, 6.
That'd be 4 to 6. 4 to 6?
Oh.
Would it be 4 to 6?
Yes, it would.
Okay. So we have the radicals here. The next thing that I keep going to I've got this prepared. The next thing that some people had questions with wasn't the geometric mean necessarily, but it was the ratio of similar solids. Okay? So you have 4 questions on your test that deal with ratio of similar solids. And we have to just let's just go back and remind ourselves that sides and perimeter have the actual scale factor. Thanks, guys. I appreciate your help. Yes. Oh, you want them? Yeah. The sides and perimeter have the actual scale factor, and that the surface areas have the scale factor. So we'll just say, I'll make up a number, 2 to 3. I'm just making up a number. So let's say that happens to be the scale factor, 2 to 3. The surface area is those numbers squared. So in this case, it would be 4 to 9. And then the volumes would have the side proportions cubed, which happens to be 8 to 27. Okay? We need to be able to go back and forth between all of these to make sure that we know what to do.
There was a homework problem I didn't do. I did not.
Okay, Sheila had a question first, and then we'll look at yours. How's that? Okay. So what can I just look at it out of the book? Do you mind? It's right behind you, honey. That's all right. 32. Okay. So 32 says sketch 2 similar. This is one of your homework problems for block 1 that you'll have tomorrow night. Just so you know, she has it. She had it last night. So it says sketch 2 similar solids whose surface areas are in the ratio 16 to 25. All right. So the surface area has the ratio 16 to 25, okay? And it said to include the dimensions. Well, if I'm trying to find the dimensions, which means I'm actually trying to find the sides, how do I go backwards? If I know the surface area, how do I go backwards? Square root. So if I'm trying to go in this direction, I actually square a cube. If I'm going backwards, I'm going to take the root, square root or cube root. So if I'm trying to go from surface area to sides, I'm going to square root. So the sides are going to have dimension of the square root of 16 to the square root of 25. Well, we all know how to reduce radicals. It's 4 to 5. It actually is a perfect square. So all you have to do is draw some solid. I don't care what kind. Okay? I'm going to pick a cone just because they're easier to draw. All right. So here, it doesn't matter what dimension we pick. I don't care. I'm going to pick the radius. This radius is 4. This radius is 5. That's good enough. That would be a sketch. Okay? I could do the heights as 4 to 5. It doesn't matter. One of the dimensions is 4 to 5. That's it. Okay? What question did you want to go over? You said you skipped it because you... That's all right. Find it. Let's look for it.
I did like these.
Was it from the book? Or was it? Okay.
Because I did.
Do you mind if I borrow your book again, Sheila?
Because I'm pretty sure I did the volume right, just the surface area.
Which number?
Page 176.
176?
I'm in
No.
746. 746.
Number what?
15.
Number.
Actually, I think it was like the surface area. Trying to find the surface area.
So down here, 18, 19, 20.
Yeah.
Okay, perfect. Let's do 18. You care? Okay. So page 747, number 18. All right. This is a good question to do.
And then
Okay.
can we do a volume one later?
Yeah. All right. So it says the volumes is given. So we're told here the volume of one is 27 cubic inches. The volume of the second solid is 125 cubic inches. So we know which one's smaller, which one's larger. And then we're given, it says we're given the smaller surface area. So I'm just going to write it over here up with the smaller one so I know. And it says 63. And I want to find the other surface area. Okay? Well, we should know that we can't do anything unless we have the ratio of the surface areas. Okay? So I need to work backwards to figure out what that is. So what I want to do is I want to find the ratio of the sides. Would you agree? Okay, or the perimeters if you wanted to, since they have the same. How do I go from the volume to the sides? Cube root it. So tell me what the cube root of 27 is. You know how to do that on the calculator? Do you know how to do that, Jason, on the calculator, cube root? You can use that one right here if you want. Good. Double check, though. Make sure you can do it. You plug it in. It goes to math, and then option 4, and plug in the cube root of 27. And you should get 3. That's where the 3 came from. And do the same thing for 125. No. Be careful, okay? Just be careful. The surface area is not 5 squared because this 3 squared is not 63. Do you see that? So what this does is it allows me to find the base ratio of the surface areas. So 3 squared would be 9, 5 squared would be 25. So the proportion that I set up is this. Because I had to take the sides and find the ratio of the surface areas. That's where the 9 and 25 came from. But I have to use the 63 in what I'm looking for, and I write a proportion. So let's think about the process. I took the volume of the ratio of the volumes, and I found the ratio of the sides. I then had to find the ratio of the surface areas, which I did here, because I just squared those. 3 squared and 5 squared. And then I take with the information I'm given, and I put that in my proportion. So this is hard because in my mind we're going backwards and forwards, I think, and that's what's frustrating, right?
I thought because for the volume we have to do it like cube or whatever. And like,
Cube root.
Yeah. And then I thought we just had to, because this is how I did it. And I realized how wrong it was. It was like I just squared it because you know how this one we had to do like that. I thought you just had to square it to get it. And then
Yeah.
realized
You have to square the side ones, but you have to go back. And actually, it would be okay. You're actually right. The cube, it's okay. The cube root of 27, really? The cubed root of 27 squared is 9.
No, but I just put it. I didn't put the cube root. I just put like
Square root?
Square root.
Oh, yeah, that's wrong. Okay, sorry.
So can I do it like the cube root?
And so
Hmm?
from
And
here,
then it would give me
The cube root of my number squared gives me that. I think though you're trying to do too many steps at once if you do it that way. To be honest with you. I mean, it's right, but I'm afraid that you're going to lose the connection if you try to do it all at one time. I would prefer you to write it out. Tell me it's 3 and 5. You know what I mean?
so then from here, we just got
Cross multiply and solve. Yep.
We get 175.
So that's the answer.
You know,
Okay, I get it.
Can we do another one where we're looking for the volume?
Yeah.
Okay.
Oh, I'm good at those. Oh, sorry.
Maybe. Let's check it out.
No, because I
All right.
understand that's the only one.
All right, so I'm going to do page 746, number 17. I'm just going to pick one. I don't care. Okay? Yes. This time you're given the larger volume, and you're trying to find the smaller volume. What do I need to do first before I can begin? Yep, find the dimensions of the sides. So how do I do that? Square root what? I'm going to leave it as a square root of 52 because it's not a perfect square. Is that okay? And square root of 208. Is that okay? It's because it's not a perfect square. If I could reduce it, I would. Like the other one was 5, right? The other one, so I could. I'm going to leave it like that. Now, I want to use the volume, right? So I know it's going to be x over 192 equals something. What numbers go on the left side? Square root of 52 cubed,
And then square root
208 cubed.
and then you
Yay!
have to multiply it.
Cross multiply and solve.
That's how I did. I think it, like in the textbook, they like that's how I can find out in the textbook. But it's like you move 129 to the other side, and then you multiply.
192, you mean?
Yeah, 192, and then you multiply everything. And then, yeah, that's how I did.
Wait, what?
That's like
So let me just see, make sure I get the answer here.
we got that. So then you just like move 192 to this, and then you can cancel and you multiply by 192. Is that like too confusing?
I'm a little.
I mean, okay. So it's like you definitely have 192 on the side. So you have to bring
24 is the answer?
yeah. So you have to bring the 192 inside, so put the x out, and then you do this like you divide it, and then you multiply with 192.
All right, where'd I lose you?
For the cross multiplying, like, yeah.
Okay, so look what I typed into my calculator.
Oh yeah.
The square root of 52 parentheses to the third power. Oh, you can't see that part, but it's up there. I'll do it again. You ready? So I said that the parentheses, the square root of 52 to the third power. Do you know how to put the third power? You put that little caret, and you hit that little caret button here, and that means up to the third power. Okay, either way, that's okay. But that's quick, it'll work. And then I'm going to say, notice I arrowed down, times 192. And I get some decimal. And then I'm going to divide by that number. Because it's this times this divided by that. So divided by, parentheses, square root of 208. Oops, not there. Really? Oh my goodness. 208, there we go, to the third power. That's where 24 came from. Okay. I think what's confusing you is that that number is it's not pretty, right? So because it's a radical and a cube, I don't think so. Well, I shouldn't say, I don't know, because I didn't write the whole test myself. Other teachers had their input, so it's possible. You're good. It's ugly, but the final answer's pretty.
When I get a decimal, I start to like
Panic. But life is full of them, so unfortunately. So those are some main ideas. We're kind of running out of time. Is there anything I can hit for you again, or the reasons to prove similar? Go ahead.
When you do the table technique,
Let's go back to one of those.
multiply, I feel like multiply all the time, like by, would you multiply 12 to get the meters and
Oh, to go from inches to feet, you multiply by 12, because this is 12 inches in a foot. But meters and centimeters, it's 100. There's 100 centimeters in a meter.
like,
What, baby? Yeah, you're talking about unit conversions?
yeah, for
Did I give you guys back your quizzes, by the way?
Yeah,
You guys made corrections. You turned it back in, but you guys got your quizzes back? Because I would go back and look at those, because some of those questions will be on the test possibly, too. Okay? Tila, did I give your class back your quizzes? The only quiz we took on this stuff. It was like on ratios and proportions. I'll look. I'll look to make sure. I think I did too.
there's also like the questions. There's like the boys.
Uh-huh.
Yeah, those I was so confused.
You have your quiz with you? Let's do one. If you have your quiz with you, we'll do one of those, and that'll be our last problem. Yep, I know exactly what you're talking about.
Really confused.
Yep. Sure. So in question number 3, it says there are 238 juniors. It says the ratio of girls to boys. So I'm gonna- thank you, baby. Girls to boys is 3 to 4. How many girls are there in the junior class? And then how many boys would there be in the junior class? So the thing you have to ask yourself is, what is 238? Is that the number of girls? Is that the number of boys? Is that the total? Okay, so it's a total value. When I'm looking at the ratio of girls to boys, do I have any total values in there? No. So I need to, if I'm going to figure out the proportion in the total number of juniors, what's the total in this ratio? 7. So that's why a 7 goes here, because it's a total value. Now, I don't care if we pick boys or girls to go in the numerator, because we have to find both in the question. I think the first one said girls. So let's go ahead and do girls over total. We don't know how many are in the junior class, but the ratio would be 3. 3 to 7. Okay? So 7 was the mistake so many people missed on this question. People put 3 to 4, and that was wrong. Because 238 is a total. Most of you did if you got it wrong. Okay? We okay with where the 7 came from? Jason, you okay with it? Yeah, now, exactly. And to find boys, you can just take your answer and subtract it from 238. That's exactly right. Are we okay with it now?
Wait, is it just means that you have to add the 3 and 4?
Because the value I was given was a total.
So we have to make.
So you just have to, every problem's different, so you just have to look at what the information was given, okay? 238 was the total number of juniors, so I know that I had to total my ratio. Okay? Okay?
We went outside to go measure the flagpole.
Mm-hmm.
Then we came back in and saw that
Mm-hmm.
at the end it was like several feet.
Well, it should have been meters, because we should have been doing all of our measurement in centimeters, I think.
Yeah. Like for number 17 on the homework.
Okay.
Yesterday,
Uh-huh. That one was in inches, though, right?
Yeah, I got
Okay. Let's do that one real quick. 17 on the homework. Do you remember what page it was?
that 460.
Jason, grab a geometry book real quick. Thank you, baby. 465?
Yes, I only do. Actually,
No, it's 456, because there was 2 pages. Yep.
I know.
It's all right.
I colored them. Sorry.
Okay, so it says that at a certain time of day, a 1.8 meter person, so it's meters, it wasn't feet, actually, standing next to the Washington Monument, okay, which we don't know how tall it is, casts a shadow. I'm just going to, you mind if I just draw 2 different triangles? To me, it's easier to see it that way. So I have 1.8 meter person, I have a Washington Monument, and here's my sun, whatever, okay? We don't know how tall the monument is, but we know the shadow lengths. The Washington Monument has a 0.7 meter shadow, and, oh, no, I'm sorry, wrong way. That would be a really tall, little shadow. 0.7 meter shadow, and this one is a 65.8 meter shadow, okay? So once you've drawn your picture, at this point, we're going to write a proportion, okay? We know that the angle that the sun hits is the same. We know that they're both perpendicular, angle, they're similar. So 1.8 over 0.7 equals x over 65.8.
Is that you have to say that?
Nope.
Okay.
I could have done 1.8 over x equals 0.7 over 65.8. There's many ways. So what you can't do is flip them. So you have to be consistent is the only problem. Right. they would correspond. Okay, so then you would just cross multiply. Of course, it ripped right out because of that silly part that's now in here. So I have 65.8 times 1.8, and then divided by 7. And so 16 point, oh, thank you. So 118.44 divided by 0.7 is 169.2. And because we're talking about meters, you can leave it like that. Okay.
Is 169 and 20 centimeters.
Yes, absolutely. You can convert it to meters and centimeters. Convert it to feet. You would take your decimal point and multiply it by 12, and that'll give you the number of inches. So if my units were feet, I would take the 0.2 and multiply it by 12, and I would say it'd be 2 inches to the nearest inch. 169 feet and 2 inches. If it was feet and inches, but it's not.
Okay, so you
Only the decimal. Yes. Okay, I'm going to stop this for the review part. If you borrowed a calculator, throw it back. If you need a bus pass, let me know.